Hello, students and fellow teachers across probably New York State. Maybe in Deutschland. Hallo. Von Amerika, meine Deutschlander Freundinnen und Freunde und Friends. Wie geht es Ihnen? Alles gut hier in America. Yeah. Okay, no more German for you. Anyway, my name is Mr. Krause from Nachbarhause. Okay, now you guys are thinking, what have I gotten myself into, and why am I watching this bald-headed freak do some math with his Dunkin' Donuts coffee? I don't know. Why are you here? Good, you're going to learn some factoring. Okay, so all of this material can be found at www.nkinfinity.com. All of my material can be found there. We're going to be doing this twice. So this video is going to be done twice. If your teacher teaches factor by grouping, some teachers call it product sum, you're at the right video, because this video is going to be doing product sum or factor by grouping. I will try not to show my bias when doing these, but we're going to do this one first. Notes, factor by grouping and product sum. Not my favorite. But it is a very useful tool, and some kids absolutely love it, even though it's not my favorite. The other way, method 2, will be guess and check. So if your teacher uses guess and check, then you want to click on the other video. And it should be clear on our website. One of these will be guess and check, and one of these will be factor by grouping. Same as 3.5. 3.5 notes, you'll recall, also had one as factor by grouping and factor by sum. So that just means twice as much work for me, so I'm going to be doing this twice. You can do it once and stop complaining. If you're feeling lethargic before you start a math video from some bald guy that's going to bore you to death for the next half an hour, you might want to grab a couple Dunkin' Donuts. They say it stunts your growth. They might be right. I have no idea. Maybe you shouldn't get addicted to it, because this is what happens. Let's get started. Gosh, 6:15 in the morning. Been up for an hour already. How many of you all can say that? All right, we're going to factor. All right, we're going to be factoring by grouping. So what we want to do is, when they're this easy, do you actually have to factor by grouping? Not so much. Not so much, but I'm going to show you the steps just because that's what your teacher might be doing, and I want to make sure that I'm following what your teacher might be doing. So I need two numbers that multiply or have a product of negative 72, but when you sum them, they sum up to equal negative 1. Well, most of you already have figured it out. It's probably 8 and 9. Now, one of them is going to have to be negative, and since they have to add up to be a negative number, the larger one should be negative. Well, you're actually done. That's the factoring. But let's do it by products, or let's do it by factor by grouping. So what we're going to do is we're going to rewrite it x squared minus 9x plus 8x minus 72. I always put the negative 1 first if I can. It just leads to less problems. So in the first grouping, I can take out an x, and I'm left with x minus 9. Copy over that sign, plus. In the second grouping, I can take out an 8, and I'm left with x minus 9. Now, if you're using factor by grouping, and this group does not match this group, start over. You did something wrong. Don't continue. You did something wrong. Okay, so because now I'm going to look at this group, and I'm going to look at this group, and I say, hey, they have an x minus 9 in common. X minus 9. If I take the x minus 9 away from them, I take that blue thing away, what am I left with? Oh, x plus 8. And there she is, kids. The final answer. The final frontier. These are the voyages of the Starship Enterprise. Going to see Star Trek tonight. So excited. Yes, it's July. No, it's August 2nd. I'm going to see Star Trek 27 million, whatever it is. All right, so you should have learned over the last couple of days that the first rule of factoring is factor out the GCF. I will never, ever make it as an announcer because I am too good. So if I look at 4 and 100, clearly they have a GCF of 4. So we're going to take that GCF out. Now, I'm not going to do dots. This is dots, difference of two squares, dots. I'm not going to do dots by factor by grouping because that's a pattern. If you recognize dots, that this is the difference, subtraction, of two things that are perfect squares, x and 25, it's a simple factoring. The parentheses are going to be exactly the same, x and x. One's going to be a plus, one's going to be a minus. That's the way you get a subtraction. And one's 5 and one's 5. Okay, that's 5. Moving on. Looking for a GCF. Now, do you all know the divisibility rule for 3? The divisibility rule for 3 states if you can add up the digits, and that's divisible by 3, the whole number is divisible by 3. So if I take 8 and I add 4, I get 12. Is 12 divisible by 3? Yep. Therefore, 84 is divisible by 3. So this does have a GCF. I'm going to take it out, 3. And I'm left with x squared plus 3x minus, anybody want to guess? You're wrong. It's 28. Now we got to find two numbers that have a product of negative 28, which means one has to be positive, one has to be negative, and a sum of 3. Now, there's only 2 real ways to multiply the 28. I mean, there's an infinite number of ways. I mean, I can do 56 times a half. Who's going to do that? You know, so you're probably thinking either 1 and 28, 2 and 14, or 4 and 7. And 4 and 7 are the winner. 4 times 7 is, in fact, 28. But one of them has to be negative. And since our sum has to come up to be positive, we want to make sure our smaller one is negative. So we're going to factor by grouping now. So we're going to write x squared minus 4x. Put the negative first if you can, plus 7x minus 28. So all we're doing is replacing the middle term with those two terms. Now don't forget, we also took out a GCF. So we're going to not worry about that GCF for now. We're just going to worry about this. We're going to factor this by grouping. We can take out an x. I'm left with x minus 4. In this, copy with a sign. And this one I can take out a 7. I'm left with x minus 4. If I factor by grouping here, look at this group, and I look at this group, I see that they have an x minus 4 in common. So that's my first set of parentheses. Ka-ching, ka-ching. What's left over? X plus 7. Second set of parentheses. Now we're not done because we forgot the GCF that we originally took out. So much fun. In my classroom, factoring is one of the F words you're allowed to say. Fun is another one. Fractions clearly is another F word you're allowed to say. So if you ever get really mad at your friend, say shut the never mind. Fraction. The only number that could work is 3. 3 doesn't go into 13. 3 doesn't go into 10. No GCF. Doggone it. Dang-gummit. So what are we going to do? Well, the product sum thing says we're going to say, okay, we're going to multiply this and get negative 30. So our product is equal to negative 30. So I need two numbers that multiply to negative 30 that have a sum of 13. Well, hopefully you didn't spend too much time on it. 2 and 15. And since they have to multiply to a negative, this one has to be negative because they want to add up to a positive. So those are our two numbers we're going to replace 13 with. So I say, okay, 3x minus 2, 3x squared, minus 2x, plus 15x minus 10. All right, we're going to factor by grouping. What can I take out of the first two? Oh, I can take out an x, and I'm left with 3x minus 2. What can I take out of the second two? I can take out a 5, and I'm left with 3x minus 2. And once again, if your parentheses don't match, if this is not the same as this, you did something wrong. So now we're going to group. Now we can look at two groups again. Group 1 and Group 2 both have a 3x minus 2 in common. So that's our first set of parentheses, 3x minus 2. Catching. And x plus 5 is our second set of parentheses. And there it is, kids. Oh my gosh, factoring is so much fun. When am I ever going to use this stuff, Mr. Krause? When am I ever going to use this stuff? Yeah, because I like to complain a lot, because I don't even know when I'm going to use it. I was like at Wegmans the other day. When am I going to use it at Wegmans? Mathematics is about building synapses in your head so that when you learn other math-related topics, chemistry, physics, engineering, whatever it is, that you're not bogged down with basic understanding of simple mathematics. And trust me when I tell you, I know you don't want to hear it, this is relatively simple mathematics. So stop asking silly questions. My goodness, you're starting to aggravate me. You don't want to aggravate me. I'll reach to the camera and give you a big hug. Oh, I won't. Oh, yuck. All right. There's a difference here, kids, and you need to make sure you understand it. It is terrible when a kid misreads a problem. There is factoring, and there is solving. One is an expression, and one is an equation. You need to know the difference between the two. We have two problems here for your perusal. One says factor completely, and it's an expression. And one says solve for x, and it's an equation. So you need to be able to understand and differentiate between the two. First thing I'll do is take out the GCF, and I'm left with x squared plus 4x minus 45. And just because I don't want to spend too much time with it, it's x plus 9, x minus 5. So what's my answer? My answer is 2 x plus 9, x minus 5. Now let's take a look at the solving over here. Oh, look, same exact quadratic, except it's got this thing that says equal to 0. So we're going to go 2x squared plus 4x minus 45 equals 0. Then we're going to say, okay, we got x plus 9, x minus 5 equals 0. So what's my answer in this case? Well, my answer in this case is, well, if I solve this, remember you're going to solve this, set it equal to 0, you get x equals negative 9, set this equal to 0, you get x equals 5. So in this case, my two answers are negative 9 and 5. If you had these directions and you gave that answer, you'd lose a point, which doesn't sound like a lot, but on a 3-point question or a 2 or 3-point question, this is probably a 2-point question, you'd lose 1 point. You just got a 50% on a problem. You did too much work. You stop right here. If it does not have an equal sign, you can't give me answers like 9 and 5. You just factor it, and you're done. Don't start tossing in equal signs where there's no equal signs, okay? And you need to be able to make sure you understand the difference between those two. Yes, I know you've done this in algebra, but just keep working. Solve quadratics by factoring. To get an equation, get the equation set equal to 0, factor completely, set each factor equal to 0, solve for x, write as a set, or write in set notation. What is the only way to get 0 when you are multiplying? So if you're multiplying, let's say A times B, and you know it has to equal 0, what do you know has to be true? Well, what you know is either A has to be equal to 0 or B has to be equal to 0. One of the two. You know, and so if A is x plus 3 and b is x minus 4, then that thing has to be 0 or that thing has to be 0 in order for it to be 0. So the only way to get a product that equals 0 is something, one of the two things has to be 0. All right, so I think we already did that. Well, we did this one earlier, but all we did was factor it. And so when we factored it, we got x minus 9x plus 8. But now we're going to add in the 0 equal to 0. So now you have the factoring part and the solving part. So now we say solve. So now we want answers. So although I'm going to show this now, I'm going to stop showing it eventually because you are trig kids, or excuse me, you are Algebra 2 Common Core students. Got to get used to not saying trig anymore. And you shouldn't have to do this. But I will show you a first few, and then we're going to stop. X minus 9 equals 0. Add 9. Add 9, and I get x equals 9. I think most of you probably are smart enough to realize, yeah, the only way to get 9 there is x has to be equal to 9. In this one right here, x plus 8 equals 0. We'll subtract 8, and I get x equals negative 8. Boom. Shakalaka. So as before, I only got factored. I only had it in factored form over here. I now want solutions. Write them in set notation. So instead of doing the boxing thing, the real nice professional way to say it is negative 8, comma 9. And I usually try to put the smaller one first. Put it in a nice set notation. It looks all professional. Math teachers like that. We're not weird. Whoever just said that. That was not nice. We took out a GCF here. If you remember, we did x squared minus 25. Now we have equal to 0. If you remember correctly, we said 4, x plus 5, x minus 5 equals 0. So in this case, I'm going to get two solutions. Now here, you know, a lot of kids get confused because I got this 4 out here, but there's no way to make this 4. This is 4 times something times something. Remember, the only way to make a 0 is if one of these is 0. Can this ever be equal to 0? No. So that can't produce a solution. Only these parentheses can produce a solution. If you take out a 4x, then you can produce a solution, but we did not do that. So the only thing we have to do here now is set these two equal to 0. X plus 5 equals 0. So I hope you realize this is x equals negative 5. X minus 5 equals 0. So this produces x equals positive 5. Look all professional. Put them in set notation. Negative 5, comma 5. And then I hear about 20 of you screaming, I don't know how to do those curly brackets. They're so difficult. Practice. Practice, 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 practice. All right, we said a few minutes ago our first step is to set this equal to 0. This is not equal to 0. Now, I know we just did this one a few minutes ago, but it's not equal to 0, so we need to bring the 84 over. So now we get 3x squared plus 9x minus 84 equals 0. We're going to take out the 3. And we're left with x squared plus 3x minus 28. We already factored this earlier, so I'm not going to go through it with you. We get x plus 7, x minus 4. And so, again, this one's not going to yield a solution. Only these two will. So I'll set x plus 7 equal to 0. And I get x equals negative 7. And x minus 4 equals 0, or x equals positive 4. And so my two solutions in nice curly brackets are negative 7 and 4. I'm with you on those curly brackets. Sometimes, some days, I just can't do it. Now, here's an interesting problem, and we put this one in here purposely because you might be inclined to do this. You're like, oh, wait, I got to set this equal to 0. Let me move that over, so we'll subtract 3x squared By the way, don't do this. If you started it, stop. 0 equals negative 3x squared minus 13x plus 10. You always want to have your squared term first. Don't do this. This is a big no-no. It only makes your life a lot more difficult. You never want to have a negative x squared. It just makes life so much difficult. So don't do this first step. So don't end up with a negative x squared. So what does that mean? Does it mean any more work? Well, not really. So really we're just going to add this 13x, bring that over, subtract this 10, bring that over. So now we end up with 3x squared plus 13x minus 10. And when I bring both of these over to that side, I got nothing left on the right side. So I end up with 0 on the right side. Now we already did this factoring already as well, correct? I believe we did. And we ended up with, what was it? 3x minus 2, I believe, and x plus 5. Yep, that was our factoring. So now we need to set each one of these equal to 0. So this first one's a little bit trickier. Set this equal to 0. Add the 2. Add the 2. But you're not done then because you still don't have x equal to 0. Divide by 3. Divide by 3. And I get x equals 2/3. So yes, 2/3 is a solution. And this one's going to give me x plus 5 equals 0. Bring the 5 over, and I get x equals negative 5. Boom. So my two answers are negative 5 and 2/3. Yes, negative 5 is smaller, so we'll put that one there. All right, you guys ready to rock and roll, get some new ones going? I am too. Oh my gosh, this is so exciting. Whoever thought that math could be so much fun at like 6 in the morning? Oh, I got in the wrong line at school. I'm just kidding, kids. Oh yeah, let's go. All right, here we go. Product sum. Product sum. I tried to convince my colleagues, and Mrs. Newman included, to do not product sum, but they are convinced it's the best way. And that's okay. That's okay. It's a cool way. It works. Not my favorite. My favorite is guess and check. It's a lot more work to begin with, but it helps out in the end. So I don't know. Who knows? If your teacher uses this method, it's cool. That's cool. If they don't, that's cool too. So in this case, the product has to be equal to negative 24. The sum has to be equal to 10. So what we're going to do is replace this middle term with whatever this turns out to be over here. So I need two numbers that multiply to negative 24 that add up to 10. Now, you got to be careful. A lot of kids are going to pick 4 and 6, but remember, one of these has to be negative. And since they have to add up to a positive, the smaller one has to be negative. Well, are these going to actually add up to 10? They multiply to negative 24, and it feels really good to have 4 and 6 because that adds up to 10 until you put the negative in front. And then they add up to 2. So that ain't going to be it. So you got to be really careful. The other way is, and the right way is, well, certainly not 3 and 8 because those don't add up to 10. But how about negative 2 and 12? Negative 2 times 12 is negative 24. And they add up to positive 10. So we're going to replace that 10x right there. So we're going to go 3x squared. And then we're going to replace it minus 2x plus 12x minus 8 equals 0. Oops, I was going to do the rest of this in a different color just so you can see it. Minus 8 equals 0. Now notice these two really just replaced that. They just replaced that. Okay, so now we're going to group. So we're going to group these first two together. The only thing that they have in common is an x, so I'll take that out. 3x minus 2 plus. The only thing these two have in common is not a 2, it is a 4. And I'm left with 3x minus 2. Now, why am I left with 3x minus 2? Because 4 times 3 is 12. 4 times negative 2 is negative 8. Okay, don't forget, this parenthesis has to match that parenthesis. And it does. We're going to group this group and we're going to look at this group. They have a 3x minus 2 in common. So we're going to do, okay, my first set of parentheses is 3x minus 2. And what's left over is x plus 4. Now, one thing I've been bad at, I just realized I didn't have that equals 0. Equals 0 says we have to come up with a solution when we're finished. So we're not quite done yet. Grab some purple, and we'll set these equal to 0. I'm only going to do the hard ones now. The other ones I'm just going to say this is x equals negative 4. I hope you can appreciate that. If you need to see the work, show the work. If your teacher makes you show the work, please show the work. I'll only be doing the harder ones now. We're going to add 2 and bring it over, so I get 3x equals 2. Now we'll divide by 3, and I get x equals 2/3. So my two answers are negative 4 and 2/3. Now, if you remember, that first step we said was you have to make sure it is equal to 0. So the first thing we're going to do is bring this negative 4x over. And we're going to add this 5. This all goes, so I'm left with equal to 0. And I've got now 5x squared minus 20x plus 20 equals 0. Now, you can go through and factor that, but it's a little bit more difficult. I'm going to notice that they all have a 5 in common, so I'm going to take out that 5. And I'm left with x squared minus 4x plus 4 equals 0. Now this is relatively simple factoring, so I'm just going to use the product sum. On the simple factoring, I'm just going to do the product sum the easy way now. So the product has to be 4, and the sum has to be negative 4. Okay, so that would be negative 2 and negative 2. They multiply to positive 4, and they add up to negative 2. So all I have to do is now x minus 2, x minus 2. So all the easy ones, and by easy ones I mean that the leading coefficient, the new, even afterwards, the new leading coefficient, which is this number right here, is just a 1. If that number is just a 1, then I'm going to do it this way. I'm still going to talk about product sum, but I'm not going to split the middle, because whatever these two answers are is what goes in the parentheses. So my two answers are x equals 2, x equals 2. Let's look all professional. You don't, since that's a double root, you just need to put it in there once. There's my answer. You guys are having, you know what's most fun is the colors. That's why I like to switch back and forth between colors, because not only is factoring itself amazingly fun, you add color to it, it's just like, it's like golden. It's like golden. I know that's what you're thinking. I wish my teacher had as many colors as you have, Mr. Krause. Okay, hopefully you noticed these add up to 9, and 3 goes into 9. So 3 would be our GCF here. So we're going to take out a 3, and we're left with 2x squared minus x minus 21 equals 0. Now, if you have an untrained mind, in your mind you said there's no way to multiply to negative 21 that adds up to negative 1. You're right, there isn't. But remember, when you're using product sum, your first rule is to get the new product. The new product is found by multiplying the 2 times the negative 21. So our new product is going to be negative 42. So I need a way to multiply to negative 42 that adds up to negative 1. Now, whenever the number is the sum, or the number in the middle is 1, that means your numbers have to be right next to each other. 4 and 5, because they subtract to give you 1. 8 and 9, they subtract to give you 1. 12 and 13, they subtract to give you 1. So you need two numbers that are right next to each other that multiply to 42. Two numbers that multiply each other that are right to 42, and our numbers are 6 and 7. Since they have to multiply to a negative, the larger one has to be negative. Okay, so we're going to come over here. We're going to bring this 3 around for the ride. So I'm going to rewrite this middle term with these two numbers now. So it's 2x squared minus 7x. Remember, I like to put the minus first. Plus 6x minus 21. Notice that these add up to that. And that they have to do. All right, so I will leave this 3 coming along for the ride. I'll group these first 2 together, and then I'll group these 2 together. So in the first 2, I can only take out an x, and I'm left with 2x minus 7 plus. Out of these 2, I can take out a 3, and I'm left with 2x minus 7. Now remember, those parentheses, this one here and this one here, they have to match. The colors, they're awesome. All right, we're almost finished. If I group this together and I group this together, what do they have in common? They have, you guessed it, a 2x minus 7 in common. Take that away. What am I left with? X plus 3. So here, just to be simple, this one is x equals negative 3. This one will do all the way out. 2x minus 7 equals 0. Remember, we're going to set them equal to 0. This one's just really easy to do. Bring the 7 over, I get 2x equals 7. Divide by 2, and I get x equals 7 over 2. So those are my 2 answers. Let's put them in nice curly braces. Negative 3, that one was not a very good one, over 7 over 2. I drink Dunkin' Donuts coffee when I do math. Do you? Nailed it! Nailed it! Oh my gosh! Someone call Dunkin' Donuts, please. I gotta get sponsorship somehow. Oh, whatever. I'll never be sponsored. I'll only be a lowly math teacher that finds math fun. Do you? No? That stinks. Subtract x. Subtract x. Subtract 8. Subtract 8. So I get 12x squared plus 6x minus 6 equals goose egg. What's the first rule of factoring? You should all be screaming it out now. You should scream it so loud your parents are like, what's going on? Thanks. You're welcome, parents. Hey, listen, if I got to put up with your annoying kids all day long, I'm giving it back to you. Obviously, they had a 6 in common, so we're going to take a 6 out. We're left with 2x squared. Now, we talked about this earlier. I have to have a plus and a minus in here. If I take the 6 out of here, I'm left with x. If I take the 6 out of here, don't think it's all gone. You still have to have a placeholder here, because remember, when I redistribute 6 times 2, I got to get 12. When I distribute 6 times x, I got to get 6. If you didn't have this 1 here, what were you going to multiply by? You have to have this negative 1 here in order to multiply to get this, okay? So remember, if the problem started with a plus and a minus, like this, and is a trinomial, and you factor out a GCF, you have to have a trinomial. All right, so let me clean this disgusting mess up. 6, 2x squared plus x minus 1 equals 0. This is not the easiest factoring. So first rule first, we got to find our new product. Our new product is going to be 2 times negative 1. So our product is negative 2. Our sum is this number, negative 1. So I need, or positive 1. So I need 2 numbers that multiply to 2. There's only one way to multiply to 2, using integers. I know you can multiply whatever, 100 divided by 50 and 1/50th. 100 and 1/50th, they multiply to 2. But nobody's going to use 1/50th as a number, so don't tell me about that. I know. So let's see. There's really only one way to multiply to 2. 1 times 2. And since they have to add up to be positive, the larger one has to be positive, the smaller one has to be negative. All right, so we're going to replace 6, 2x squared minus 1x plus 2x minus 1. Now, I didn't need to put that minus 1 in there, that minus 1x, the minus 1. I just did it for you because that's the kind of guy I am. Notice these two add up to 1, so we're doing good shape. Keep the 6 coming along for the ride. Don't forget that 6. It's part of the factoring. It's not. It actually has nothing to do with the solution, only because it's just a plain old 6. What can I take out of these two? Just an x. And I'm left with 2x minus 1. Plus, what can I take out of these things? Shoot. I can't take anything out. Nothing. Wait. What is that one number that everything has in common? What do all numbers have in common? All numbers, I don't care what it is, all numbers have this as a factor. So when you're sitting there going, I can't take anything out, take out a 1. They have a 1 in common. So, because I can multiply 1 times anything and it doesn't change its value. So 1, 2x minus 1. Again, make sure you understand that 1 times 2x is 2x. 1 times negative 1 is negative 1. So I was able to take out a 1. Okay, so again, remember, this has to match this. If they don't match, you did something a little bit messed up, okay? So we're going to factor this group, and we're going to factor this group, leaving the 6 along for the ride. All right, so what do they have in common? They have a 2x minus 1 in common. Gone. Gone. Remember, take it away, take it out of both, and I'm left with an x plus 1 as my other factor. All right, we're almost done. This one is just x equals negative 1. Yes, I know some of your teachers make you show that work. I do not, and I don't really care in my class, but if you're whatever your teacher asks you to do, please do so. They've got a reason to do it their way. And then we're going to do 2x minus 1 equals goose egg, bring the 1 over, I get 2x equals 1, and divide by 2, and I get x equals 1/2. So my two answers are negative 1 and 1/2. Yes, I put the smaller one first. Are we done? We're not done yet. We got to have more. There's got to be more. Oh, yes! Thank goodness. Oh, whew, I thought we were done, and I was just going to be sad because I got to do this all over again. The other way. All right. Oops. That's me. That's the video editing software I use. You don't want to buy it. It's expensive. Okay, so the graph of the function f of x has an x-intercepts of this. Write the function in standard form. So they're asking us to work backwards. They're telling us that our answers, when we're done, are x equals 3 and x equals negative 2. Those are our answers. So they want us to work backwards. They're saying, okay, write a function in standard form. Working backwards. Now, if you remember correctly, come on, move with me. Move with me. There we go. When this was a negative 1, where did it come from? It came from positive 1 parentheses. When this was a negative 3, where did it come from? It came from positive 3. When this was a negative 4, where did it come from? It came from positive 4. So as we're going back to do this problem and we're working in reverse order, you could say, oh, wait a second. Because that's an x plus 2, minus 2, that means it must have come from x plus 2. And because this is an x equals 3, that should have come from x minus 3. Now let's make sure it makes sense. If you plug a 3 in here, doesn't that thing become 0? If you plug a negative 2 in here, doesn't that become 0? Absolutely. So we're almost done. Not quite. We still just got to work in reverse order. You got to double distribute this stuff out. So if I double distribute this, I get x times x is x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x. And negative 3 times 2 is negative 6. I'm almost done. F of x equals x squared minus x minus 6. And this is the answer to the question. All right. So we're going to do it backwards, but we're going to do it starting from top to bottom. So we're going to write our function g of x. If negative 5 is a solution, x plus 5 was one of my roots. Excuse me, one of my factors. If 1 was a solution, x minus 1 has to be one of my factors. Double distribute, and I get x squared minus x plus 5x minus 5. Keep going. G of x is equal to x squared plus 4x minus 5. And there is our solution in standard form. Almost done. 2 problems left. Anybody sad that there's only 2 problems left? I mean, you could just... Factoring is so much fractioning fun that I can fractioning factor all fractioning day. You know what I'm fractioning saying? I hope not. Okay. Write an equation. Write the equation in standard form. So if you want to, now you can just use y. You could use f of x if you want to. But if negative 6 is my root, then my factor has to be x plus 6. And if positive 6 is my root, then this has to be x minus 6. Now, you should recognize this as dots, difference of 2 squares. Because remember when we had dots? Remember that pattern? You got this? So I know my answer is going to be... I know that my answer is going to be x squared minus 36, you know, because this is dots, difference of 2 squares. But if you need to see it, let's distribute. X times x is x squared. This is negative 6. X, this is positive 6x. And then the last is minus 36. Notice these two will cancel each other out because one's positive, one's negative, and there's your answer. Uh-oh, SpaghettiOs, we got a half in a problem. We want to write it in standard form. So we need to come up with h of x, and we want to know what a is, what b is, and where c is. So our goal is eventually to figure out what a, b, and c are from this mess right here. Anybody scared? Anybody scared? I'm not. I'm not. I'm going to man up here. H of x is equal to, no big deal. They gave us the roots. These are the roots. These are the zeros. If that's a plus 8, this goes minus 8. If that's a negative 1/2, in here goes a positive 1/2. Now, I know you've never factored like that before, but that's all it means to be a root or a zero is that it came from that parenthesis. So that's no problem. Let's just double distribute. X times x is x squared. X times a half is plus 1/2 x. Negative 8 times x is negative 8x. And negative 8 times a half, negative 8. What's half of negative 8? It's negative 4. So h of x is equal to x squared plus, now these combined, they don't give me a plus, they actually combine to a minus, now negative 8 plus a half, or 8 minus half, that's 7.5, minus 4. So what's A? A is 1. What's B? B is negative 7.5. Be careful, the sign comes with it. And what's C? C is negative 4. Yay! We're done! We're done with day 6. The first time through. I get to do this again. Yay! I have twice as much fun as you. Hit the subscribe button, hit the like button. Let me know what you think. Did my hair up all good for you today. Goodbye, kids. Have fun with math. Stay awake. And be nice to your math teacher. You heard me.